Good evening, my lovely warriors. And do you see some difference in the first 5 seconds? Well, I'm back and there are a lot of updates out here. But before we begin, let me tell you all about what we're going to see today. Look at this beautiful picture. Couldn't have been possible without reflection. Look at this. I'm pretty sure most of you would have done this in your school, with your friends, with your watches, or some kind of a reflecting surface. Hold a mirror and then point it towards some friend or somebody who you want to irritate. And if you've done that, please raise your hand in the chat box. All of this with me, Shreyas, your physics master teacher, and Vedantu going live. And finally, I'm back on the big screen. I hope you guys can hear me loud and clear and see me all bright. Good evening, Anish, Gokulnath. Welcome, Ishwar. Welcome, EGL, Stimulating Tech. Welcome aboard, all my lovely warriors. So, what are we going to see today in the lecture 1 of ray optics? We are going to see the laws of reflection. Yes, then we are going to go to the types of objects, the images in detail, and some really interesting questions with image formation, deviation of light, with multiple mirrors, single mirror, also objects moving, mirrors moving. In fact, they will be also moving at angles, and then also multiple images formed with multiple mirrors. All of this in today's class, and next class will be on curved mirrors, and then we'll go to refraction and lenses, prisms, all of this in your favorite channel, JEE Enthuse. And if you haven't subscribed it yet, please do that right now. Hello PL, hello Panindra, Heman, Koyur, Uncharted, good evening Steve, welcome Neha. Yep, so glad PL you watched my recorded classes and welcome to the live class. It's going to be a very different experience. Yep, Anish, if you have any general questions, you know there is a best place where you can get all your questions answered. Number 1, in the YouTube comment section after the video ends. Or number 2, on my Instagram handle, just drop me a message. I'll definitely help you with not just generic but also even specific queries. I hope that makes sense. Kaushik, good evening and welcome back you too, Deepa. Well, let me also tell you one more thing. Well, I finally tested negative, number 1. That's the reason I have also shaved. You can see that. I'm back on big screen. I'm back to Bangalore. So all the lectures henceforward will be in the big screen. Ishwar, I'll take care of the echoing maybe someday later. I need to put up a lot of anti-echoing material. I need to put some absorbers behind the camera and all of that. So I'll do that, don't worry, I'll definitely do that. Yeah. So this is Pathfinder unknown. I know Pathfinder is not mentioned on the top, but this is the Pathfinder series continued. Alright, so let's get going, and I hope you have already smashed the like and the subscribe button. The reason why I tell you to do so, first, if you are new to the channel, then there's a very important thing you need to understand. This is the only English medium channel which has been running for more than a year. Number 2, we are the first ones to, in fact, continue support to all kinds of exams, that too in English medium. Number 3, we take care of all the exams like KVPY, BETSAT, JEE Mains, JEE Advanced, any board related stuff as well during the exam time. And if you are already subscribed, you should definitely hit the like button because it shows your support and gives us that boost and the confidence to give and conduct more such amazing sessions just for you. Alright, so let's begin. And also let me tell you at this point of time that some of you might not know this, that there are more than 1,000 students, 1,500 students who cracked JEE Advanced from Vedantu alone. It's a massive number, and this year too we are going to come back with great numbers. And if you are a 2022 aspirant and you want to push yourself, if you might be at 10,000 rank, you want to push yourself to below 5,000 rank. If you are at 5,000 rank, you want to push yourself under 1,000 rank. So you want to push yourself and you want to cover up, revise the syllabus, you want to get an amazing JEE Mains rank, you want to make sure you attend all the mock tests apart from the ones which are probably available freely online but they are not up to the mark. You want the report cards, you want to compete with the real people, and you want the actual assignments of JEE level. then go ahead, check out the JEE crash course which is there in the description box, because today is the last day of the sale. There is 2000 rupees off which is going on right now. That is 50% offer right now. It is valid only till midnight. Tomorrow onwards it will be back to 10%. So go ahead, check it out, because the crash course has started today and you definitely want to get into the new batch. Let's get going and let's get started. So Rahul, like I have said in my previous video, please watch that video. When will the JEE be conducted, the JEE expected timeline? Just check it out. I have explained everything in detail. Tarsha, nice to see you back as well. Uncharted, same thing. Just watch the JEE video. If any new update comes, I'll definitely let you know. As of now, there are no new updates. Yeah. Is it possible to crack JEE Mains in preparation from 11th? Yes, Anish, definitely. Definitely. Now, let's get started then. Alright, so just hold on. So, first of all, the laws of reflection. These are very easily understood. These are like probably also seen by you during your earlier lower grades. So, we all know that whenever any light falls on any surface, it gets reflected, and the incident ray, the reflected ray, and the perpendicular drawn to the surface, they all are in the same plane. Not just that, yes, the angle at which the light falls with the normal, which is called as the angle of incidence, and the angle at which it gets reflected, they both are equal. This is very straightforward. There is nothing great about it. This you would have already learned in your lower grades. It's a very easy law, very simple law. There is one interesting thing though, which I would like to mention at this point of time. If incident ray is given by I hat vector, it's a unit vector in the direction of the incident ray. N hat vector represents a unit vector in the direction of normal, and R hat vector is a unit vector in the direction of the reflected ray. Then remember the scalar triple product, which is as shown, the scalar triple product, the scalar triple product, which is I hat dot n hat cross r hat. Now you can change the order, it really doesn't matter. You can put r hat first, really doesn't matter. This value will always be 0. The reason for this is that whenever three vectors are coplanar, then their cross and dot together, which is called as the scalar triple product, triple because there are three numbers, is always going to be 0. This is basically a test. This is a test for coplanarity. This is a test for coplanarity. Remember that. So whenever three vectors are coplanar, you can always take the scalar triple product. Yet, not collinear. Collinear is different. Collinear is along the same line. This is coplanar. So they are in the same plane. So when three vectors are in the same plane, that's when the scalar triple product will be 0. Alright, so let's get going to the next one. And before I go ahead, let me also tell you, whatever I write on the screen will no longer get erased. And if you are happy about it, show your happiness in the chat box. You will get the entire handwritten notes, whatever I write on the screen, because I have now shifted to PowerPoint. And you will get it in the Telegram channel. Yes, join the Telegram channel. The link is there in the description box below. Now, I can already see the happiness. Very good, Thalapati. Thank you so much. But still the angle between them is not 90 degree. No sir, yes, the angle may not be 90 degrees. Yes, that's possible. Yeah, very good. Okay, next up ahead. The different types of beam, very straightforward. These are some things which you should know before we start the chapter. So I'm doing a quick revision. The different types of beam. Beam, what is the meaning of beam? Beam means a collection. This is nothing but collection of light rays. This is nothing but collection of light rays. So this is nothing but a beam. There are three different types of beams which you have to know about. One is a parallel beam. Parallel beam means all the rays are parallel, obviously. Divergent, the rays go far away. They drift apart. They become far away. And here they come closer. Here you can see they come closer, so that is a convergent beam. So three very important types of beam, standard definition. There's nothing great about it. Let's move ahead. Okay, next, object. Different types of objects that you need to know about. Number one, point object. Number two, extended object. See, what's the difference between the two? Most of the times, point object is shown like a dot or a circle, small circle. Extended object is generally shown with an arrow mark with a ray-like symbol. The difference is, for a point-like object, okay, for a point-like object, alright, understand, it's just one point from which the rays will emit. It's from one point where the rays will emit from that object, emit or it might be reflected. But from an extended object is made up of multiple points. Point 1, point 2, point 3, in fact, infinite points. And each point will give rise to infinite rays like this. So there will be many point objects which will be coming out of it. Point objects which it is made up of, and many rays which will be coming out of it. So an extended object is nothing but made up of many points. That's what I would say right over here. So just put it eraser and I'll just write it down over here. So an extended object is nothing but made up of many points. They are made up of many points. That's all. That's an extended object. In general, you are an extended object. Anything, this remote or this pen, my watch, everything is an extended object. As simple as that. Okay. Image. Again, in image also can be of two types. Point image or an extended image. Usually you are going to see for a point object you will get a point image, and for an extended object you will get an extended image. And you might be wondering, sir, why are you telling that word usually? Is it possible that you have an extended object and you get a point image? I think it is possible. Just refresh your memory, go back in time and try and see if there was a situation which you have learned where you had an extended big object whose image was very teeny weeny. Yes, it is possible. Imagine you have a big object very far away and the rays finally converge at the focus. They finally converge, they meet at the focus. Imagine it's a lens or a mirror, curved mirror. Then what will happen? The image will be a point image, right? Makes sense. So it is possible that you have an extended object and the image can be, a very small. Sonal Ralkar, I'll definitely take care of the voice echoing part tomorrow, bacha. For today, just bear with me. Okay, today only I had to set back my studio, so there could be some issues, just ignore that, alright. Yeah, so again, the same thing, the image can be also of two types, but when I talk about an image, what exactly is an image? Image is a point or a set of points where the rays meet or appear to meet. For example, you stand in front of the mirror, you look at yourself. You see a replica of you inside the mirror. What exactly is the replica? It's your image. That image means the rays of light appear to come from that point or points behind the mirror. Because the rays from you, they bounce back from the mirror. And they appear to originate from the points behind the mirror. So that's what an image is. And there are simple ways for locating where is the image. The image, for it to be located, for you to know where it is, you need minimum 2 rays. Yes, if there are 5 rays, very good. But minimum you need 2 rays. Keep this in mind. Also, remember, even if it is a curved surface, I'll just put it up here. Imagine, even if it is a curved surface like this curved surface is made up of many plane mirrors. Think of it like that. That means, if the rays of light fall here, they will follow the laws of reflection, assuming this is the normal. If the light rays fall here, they will get reflected like this. This will be the normal. Each of them is a plane mirror. Laws of reflection, incident equal to reflection, plane is same. All these things are obeyed even in a curved mirror. In fact, also remember that when two rays will meet, because you need two rays, only then you can say the image is formed, or they should appear to meet, or they should diverge from a point. So there should be some intersection of the rays even when you pull it behind or pull it forward. Only then you can say that the image is formed. Okay, now there are two types of images based on how they are formed, and one is real, one is virtual. You might have heard about it. What is real image and what is virtual image? Probably you need some refresh of your memory. Let's do a quick refresh. What's a real image and what's a virtual image? Just hold on, let me just go forward. Yeah. So first of all, in a real image, you will see that the rays converge. Look at this. If two or more rays actually converge, they meet at a point, then it is a real image. And it so happens, if you take a screen and place it over there, then you can see it. You can see the real image on that particular screen. Best example is your cinema hall, theater. Have you seen that there is a projector behind? How many of you have seen that? Hi Jay, good evening. Welcome aboard. Yes, so it's not a one shot of ray optics. Ray optics cannot be completed in one shot. It's a one shot of plane surface reflection. So those rays, they meet on the screen. That's where the image is formed. Without the screen, you would not be able to see it clearly. So that's why you need a screen to see that. Otherwise, it will be very difficult for you to see the movie, obviously. Similarly, in a virtual image, what happens is that the rays appear to originate when extended backwards. So you extend it. You extend the rays backwards. So these are the rays. And you will see they will meet somewhere over here. This is a virtual image. Example, you see through a magnifying glass, or you see yourself in the mirror. The rays appear to come from behind. This is where you are standing. The rays appear to come from behind. That's a virtual image. Yes, you see something through a magnifying glass. The rays appear to originate from a point behind. That's a virtual image. Believe me, just like you have virtual image and real image, similarly you also have virtual object and real object. Yes, you have two kinds of objects. Not many people know that. Yep. Is it my new smartboard? No, Deepak, it's not a new smartboard. It's just that I have shifted to PowerPoint. Earlier I was using Google Slides. That's the reason why it looks a little bit different. Yep. Now, a real object. Real object is like this pen. I know this is real, but the true definition of it is the ray should originate from that object. When the rays actually originate, or basically this pen is there, you can see the light rays are originating from here. That's a real object. Okay, that's the definition of that. Virtual object is when the rays appear to meet, but they do not actually meet. Only when you extend it, they meet. That's a virtual object. Keep this in mind. Alright, so what's a virtual object? Virtual object is when the rays appear to meet when you extend the rays. That's the difference. They are very, very similar. If you notice, look at this real object. The rays actually originate. In real image, the rays terminate. Look at this. Rays originate in real object. In real image, the rays terminate. Do you see that? Next thing. In virtual object, the rays appear to meet when extended forward. When extended forward, the rays appear to meet. In virtual image, the rays appear to meet when extended backwards. That's how you can remember it. Is that clear? This is a very, very important slide. I hope everybody is clear about this. Yes, there will be lots of questions. I'm just going to go through the theory quickly, and all these slides are going to be there in your session PDF. I have mentioned everything in detail. Okay, what are the important points that you need to know from boards, from mains, from JEE perspective? All of this is there, and whatever I write on the screen will also be available for all of you in the PDF. And yes, if you are joined in late, please make sure you hit the subscribe and also hit the like button, because only then you will get the recommendations from YouTube, else you might skip and miss our videos. Let's solve the first question for today. Which of the following are true? More than one can be correct. You can photograph a virtual image. Real images are formed only when screen is present. For an object placed in front of a mirror, the image is virtual. Real images can be photographed. Let's see how many of you can understand this. Aryan, I'll explain the graphs of V and U when we discuss curved mirrors, lenses, etc. Today we are seeing only plane mirrors. Yep, it's a very important topic. Let's see how many of you can get the correct answer. Alright, so many of you are saying C, only C. Utkarsh saying A and C. Hi Ramya, welcome aboard. Alright, Anish also saying C, Ishwar saying D and C. Well, the correct answers are actually A, C and D. And I'll tell you how. Can you photograph a virtual image? Obviously yes. Have you not taken a mirror selfie? How many of you taken a mirror selfie? Have you? When you look at yourself in the mirror and you take a photograph, what happens? You are seeing a virtual image, right? And you're taking a picture of it using your camera. Obviously. So hence, you can photograph a virtual image. Mirror selfie is the best example for this. Alright. Then, what is the next thing? Let's have a look. Real images are formed only when screen is present. Wrong. Real images will be formed whether screen is present or not present. Only when the screen is present, you can see it. The image is formed. The real image is formed irrespective of whether the screen is present or not present. So the mere presence of a screen just helps you to see it very easily. That's all. So that B option is wrong. For an object placed in front of a mirror, the image is virtual. When you place an object in front of the mirror, yes, the image is virtual. You can see that. When you stand in front of a mirror, the image, the behind you is obviously virtual. That's true. That's obvious. Real images can be photographed. Guys, have you not taken a picture of a movie in a theater? In a theater? This is piracy, by the way. This entire thing, if you do that, that's piracy. So you might have seen some pirated copy of a movie. What is that? The image on the screen is real image. The image on the screen is a real image, and if you take a video or you take a picture, that's piracy. That's not supposed to be done. Isn't that right? I hope this is clear. Aryan, this is a Pathfinder series only. Okay? So this is our Pathfinder series. We are not dismissed Pathfinder series. I am the one who is continuing it. Alright? So maybe the title is not mentioned as Pathfinder, but guys, if you have forgotten, we completed light waves, we completed EM waves, term 2 syllabus. And yes, now we are on to ray optics. The only topic remaining after ray optics is modern physics semiconductors. That's it. Yeah, this is 12th standard topic only. Now, what kind of images do you get by a plane mirror? Now that we spoke about general images, objects and all of that, what kind of images would you expect out of a plane mirror? See, very simply put, let me just show it to you over here. See guys, it's very easy. When you have a plane mirror like this, and let's say this is your object, okay, this is your object right over here. If you draw even two rays, that's enough for me to figure out where the rays will meet and where the image will be formed. For example, I draw a ray like this, it will reflect like that. I can draw maybe one more ray like this, it will reflect back like that. So these are two rays which are sufficient enough for me to locate the image. All I need to do is extend them backwards. I just need to extend them backwards because that's the only way they will meet, somewhere over here, and I will see this is where the image will be formed. Now, imagine this is a point object, it's a point image. If I have multiple points, there will be multiple point images formed. That's what has happened here. This is an extended object. You will get an extended image. Is that clear, my warriors? If you have multiple points, you will get multiple images. For each point, each image. each point corresponding, you will get one image correspondingly. That means for an extended object, you will get an extended image. Now also notice, because all the angles etc. are equal, one can easily also say that this distance is also equal to this distance. The distances are the same, and if you place an object like this, the image will also be like this. That means the image will be erect. The image will be erect, and it is virtual. It is virtual. It's a virtual image, it's an erect image, and it is also of the same size. But there is one catch. There is one catch. What is that one catch? The image is laterally inverted. It's as if you are a born right-handed person, then the image of you is a person who is left-handed. Just imagine there is a mirror over here, and if I am a left-handed person, then my image will be a person who is right-handed. That's how cool it is. Yeah. Alright. So things change. There is a lateral inversion. Yep. If you buy a right shoe, you have two shoes, right? A pair of shoes. Left shoe, right shoe. If you place a right shoe in the image and behind the mirror, it becomes a left shoe. Very interesting. If you look at the clock, if the clock turns clockwise, in the mirror it will turn anti-clockwise. Very, very interesting. A clock turning clockwise like this, in the mirror it will turn anti-clockwise. Everything is inverted. It's like a new world. It's a new world, completely opposite, completely twisted. Alright, so with this, let's solve some questions, and I have placed all the properties of a plane mirror's image right over here. Image sizes, object size, image distances. Object distance, image is erect, image is laterally inverted, image is always virtual, which is the one behind the screen. Alright, moving on to some question. Beautiful question coming up in your screen now. In the arrangement shown below, the image of this object because of these two mirrors will be. It's a very tricky, very intellectual question. Many people will fail over here. Let's see how many of you can do this without getting it wrong the first time. Come on, my warriors, think about it. Yep, Wati is back on the board. Ankit saying B, interesting. And I'm Shomer, yes Jagdish, looks like you have tried to relate organic chemistry back in physics. Look at this object, draw the rays or think about the images being formed and see where the image will be formed. Based on that, figure out will the observer. So meanwhile, you are solving the question, I'm just going to draw the observer right over here. So our observer is over here, like this. Okay, this is our observer. And he is looking, okay, his job is fun. Okay, that's why he will be always observing, listening. He was there in Doppler effect, he was there in so many chapters. He's always observing, so jobless fun. Okay, so think about this question. What do you think will be the final answer? Many people getting confused between D, C, B. Interesting. Let's see what is going to happen. Okay, I'm going to draw the normals first, because only when I draw the normals I get a good idea of what is happening. So this is the normal for this. Okay, this is the normal for this, and this is also the normal for this. Okay, this is the normal for this. Now, for the first one, here is what is going to happen. This object, okay, is 45 degrees in front of the mirror. The image will be 45 degrees behind the mirror. I will repeat. The object is 45 degrees in front of the mirror. The image will be 45 degrees behind the mirror. So 45 plus 45 is 90, right? 45 plus 45 is 90 degrees. So the image should be formed somewhere over here, and it should be formed like this. Just check this out. This is your image 1. Does that make sense to you? If the object is here, the mirror is like this, the image will be formed here, right? Everybody agrees to this? If the object is pointing like this, the mirror will form the image this way, right? Everybody agreeing to this point? Now, this image, mind it, my warriors, will become the object for next mirror. This will become object for the next mirror. Which is the next mirror? This is the next mirror. Now think carefully. Think carefully. You will see this object for the next mirror. This one is making 45 degrees again, because if this is 45, this is 45, this is 45, this is 45. Obvious, right? So this is also 45 degrees. If the object is 45 degrees in front of the mirror, the image will be 45 degrees behind the mirror. 45 degrees in front, 45 degrees behind. 45, 45, 90. So the image will be formed somewhere over here, right? This will be the image which will be formed by the second mirror. Isn't that right? And isn't this image erect and virtual because it is behind the screen? Sorry, behind the mirror. It is behind and it is upright. It's upright. That means it is erect. That means the correct answer should be for this question virtual and erect. Yes, that's the answer. Isn't it an amazing question? Yes, Jagdish, these are interesting questions. And guys, if you follow me, I have made sure that the questions are very different, and henceforward it's going to be a revolution. You're going to see a lot of changes coming in. I was just waiting for my COVID to get over. I was just waiting for me to come to Bangalore because I wanted the big screen. I wanted this PowerPoint so that all my notes are there. You're going to see a lot of changes in my presentations. You're going to see a lot of changes in my questions in the days to come. Yep, you're going to see that. So all I need is your motivation, your support, your love. Yes, when this happens, that's what gives me motivation. Nothing else gives me motivation. It's all your love, nothing else. Alright? So let's get moving to the next question coming up on your screen now. You want to yes, Ankit, I'll be doing sample paper solution maybe tomorrow or day after. I was supposed to do it on Saturday, but my internet connection just gave up on me. So I'll do it maybe tomorrow or day after. I'll let you know, definitely. Also, I'll do the analysis part of it. It is designed to photograph the image of an object placed at a distance of 3 meters in front of a plane mirror. The camera, which is at a distance of 4.5 meters from the mirror, should be focused at a distance of. Think about it. Glad, Gobulnath, you're very happy. Yep. So, no, Utkarsh, that's not true. That's not true. Okay, so the object is not virtual, the object is real, Utkarsh, for the second mirror, because the rays appear to originate from a point. So if the rays originate from a point, the object becomes real. The image can be virtual, but the object will be real. Understand that? Yo, let's see how many of you can get it. How many of you can get it? Let's see how many of you can understand what is exactly asked in the question. You want to photograph the image of an object, not the object, the image of an object, which is at a distance of 3 meters in front of that plane mirror. So this is our plane mirror, and in front of it 3 meters. So let me just mark 3 meters over here, which is placed. This is the object right over here. The camera is at a distance of 4.5 meters. So here is our camera. The camera right over here. So this is our camera. Okay, interesting. So this is our camera. Right, interesting. Which is at a distance of 4.5 meters. Now think, if this is the object, where will the image be formed? Obviously, my warriors, the image will be formed here, right? This will be the image of an object, and obviously that distance will also be 3 meters. Now forget you are looking at this. Think as if you are looking here. Think as if you through the camera are looking at this image. So where is that image, my warriors? Think about it. How far is that image from the camera? Isn't it at 4.5 plus 3, which is 7.5 meters? Isn't that right? So shouldn't you focus at 7.5 meters? Got it? Very good, Utkarsh. Surendra, HCV, if you are not able to solve, watch my classes, number 1. Number 2, watch my micro course on HCV solving short answers. Number 3, see my numerical problem solving micro course. Also, try from basic, then try to read the theory, make your notes, then you will be definitely able to solve HCV. Alright, so let's get moving to the next one. Yes, the correct answer is 7.5 meters. Moving to the next question. There is a man, he is 180 centimeters tall. His eyes are 10 centimeters. So from his head, 10 centimeters below his head. In order to see complete image of himself, okay, right from the head to the toe, he uses a plane mirror which is at a distance of 1 meter in front of him. Start drawing this. Start drawing this. Okay? Yep, Gokul. The last 5 questions are always very good. They are really challenging even for JEE Advanced student. The minimum length of the plane mirror required is. Let's start drawing this. Without that, we will not understand it. So, let's just assume this is that Pandu who wishes to see himself. This is his eyes, and that's at 10 centimeters below his head. Okay, this is his head. Alright, this is his beautiful hairstyle. Now he has a plane mirror right over here. Okay, he has a plane mirror right over here, and it is at a distance of 1 meter. Okay, it's at some distance. Fair enough. Now, if he wants to see himself, how much is the size of the mirror required? Whenever you see the questions where field of view or the size of the mirror is involved, I will repeat. Whenever you see questions on field of view or size of mirror involved, then these kind of questions are very similar. All you need to do is draw that mirror as much as needed, okay, and then forget that the mirror exists by drawing the image. Draw the image as if the mirror is not at all there, and then visualize everything forgetting the mirror. So where will the image be formed? Obviously at the same distance. Obviously at the same distance. If this is D, this will be also D, and this is how the image is going to look like. Okay, this is how the image is going to look like. Perfect, right? He should also have the same hairstyle like this. Now, if this guy wants to see himself completely from head to toe, that means the rays from the top should enter his eye. So the rays from the top of his head should enter his eye, and the rays from the foot should also enter his eye like this. Now you will be like, sir, actually the rays won't come from here. What are you drawing? Guys, this is just imaginary. Actually what is happening, the rays are coming like this and they are getting reflected. The rays are coming like this and they are getting reflected. Instead of showing those reflections and confusing you, I am only showing you the image, forgetting that there is a mirror. And now think, all the other body parts will be passing through this much region. All the other body parts, you will be seeing that it will be passing through this much region. Is this part or this part of the mirror even useful? No, right? Because all the rays are passing only through this much region. So only you need this extreme point and this extreme point. This part and this part is useless completely. Now, I want you to see this very, very clearly. Look at this triangle. Look at this triangle. Can you see this beautiful triangle? And look at another triangle which I am going to show it to you right over here. Like this. Look at this triangle. Look at this triangle. These two triangles, if you can see this very, very clearly, very, very important triangles right in front of you. This triangle and that big triangle. Aren't they similar triangles? Tell me, my warriors, aren't they similar triangles? Yes or no? Aren't the triangles similar? If the triangles are similar, the sides are in proportion, right? The sides are in proportion, 1:2, 1:3, whatever is the proportion. Everybody gets this? Everybody gets this? The sides will be in proportion. Now, look at this. This small triangle, if it has a height of D, the big triangle has a height of 2D. If the small yellow triangle has a height of D, the big triangle has a height of 2D. That means the sides are in the proportion of 1:2. Small triangle is 1, big triangle is 2. That means if this Pandu's height, if it was h, my dear warriors, then how much should be this much? If this is h, which is base of a big triangle, this is small, chotu triangle, this will be h by 2. Hence the answer will be h by 2, which is 180 divided by 2, which is 90 centimeters. That's option B. That's how you solve it. Okay, yes, length should be half, shiny, but the best part is the distances did not even matter. This eyes distance did not matter. The person and the mirror distance did not matter. So all that data was useless. Even if his eyes were not 100, but yes, let's say 20 centimeters below, it wouldn't matter. If you are standing 10 meters away from the mirror, still the answer will be same. So all that data was just given to confuse you, nothing else. Remember that. So you just need half of the mirror. Yeah, just SSS similarity, correct. Moving on to the next one, 90 centimeters was the correct answer. So I have put it up just for you. Minimum height required to see the full image, irrespective of the distances, is always half your own size. This is another beautiful question. Yep, and many students do not know how to solve this, but again, this is a question on field of view. Field of view means till what point are you able to see the image, or how much mirror will you need to see the image till this point of time. So it's a field of view kind of a question. You have an object here. Point B is the object. It's at a distance of L in front of the mirror. Fair enough? The mirror is only of limited thickness or limited size. You are walking at a distance of 2L. Think there is a mirror here, there is an object here. You are walking little bit far away, 2L distance, and you are going from minus infinity to plus infinity. There will be a region in which you will be able to see the image, because if you go too far, you won't be able to see the image of this object B in behind the mirror. So the question is the greatest distance over which he can see the image behind the mirror. That's the question. Yeah, let's see how many of you can do this. Very, very important. What did I tell you? Whenever you see field of view means till what extent can you see the mirror or mirror's image. That's all. So all these kind of questions or minimum size of the mirror questions, always forget the mirror. Always draw the image of the object. Okay, and solve the problem as if the mirror is not there. So this is the object. Okay, let's start doing this. Where is it? Oops, not this. Okay, there we go. Okay. So this is basically our object. Let me draw the image first. It will be right behind. So this will be the image. Okay, this will be the image. I will call it B1, the object, and this is the image. Forget that the mirror is there. You just need to understand the rays will reflect only in this particular region. If a ray comes over here, there is no way it can reflect. This is not possible. But if a ray comes here, then it will reflect. Understand? So here, if the rays come, they will just continue to go like this. There is no way it can get reflected. So there is a limit till which he can see. So what I will do is, okay, I'll just forget this parts out here. Just hold on. I don't need this anymore. All I'm going to do is draw the extreme rays. Extreme rays will be somewhere over here. Look at this. Till this point. And starting from here till here. That's it. These are the extreme most rays. That's it. Okay. This ray and this ray. That's it. These are the extreme rays. Now, this person is walking at a distance of 2L. So let me just show that as well. Right over here. Alright. So he's walking at a distance of 2L. Right over here. Again, I see two triangles. I don't know whether you have seen it, but I can definitely see two triangles right over here. One triangle is this triangle, this small triangle out here. And the other triangle that I can see very easily is the big triangle right over here. I feel these two triangles are similar to each other. That means the sides will be in the same ratio. What is the ratio of the sides of the similar triangles? Just tell me that. That's it, you'll get the answer. Think about it. If this is L, the image will be also formed at a distance of L. So the height of the small triangle is L. The big triangle, the height is 3L. So the sides are in the ratio of 1:3. Understood? If this small triangle is height L, the big triangle is L plus 2L, which is 3L, 1:3. That means if this is D, think about it, my warriors. Now, if this much, only this much is D, because that's the size of the mirror, this will be obviously 3D. So till 3D, he will be able to see the image. Beyond that, he will not be able to see it. Hence, the correct answer is option D, 3D. Very good. Not 1:2, it is 1:3. Yeah, a lot of students make that mistake also. Okay, so beyond this point, you will not be able to see. So you can see the use of geometry, which you have learned back in 8th and 9th grade, being very easily used over here to solve the problems of ray optics. Also, do you know, ray optics in many books is also called as geometrical optics. Reason is, a lot of geometry is involved and many students do not know, and they feel that ray optics is all about formulas and remembering all those basic definitions and all of that. No, it's also a lot about geometry, which you have studied back in your lower grades. 3D is the answer. Deviation. Yes, Dinesh, you will get more strategies. For now, watch my strategy session, which I conducted long time back, maybe around 2 weeks. Watch that. At least follow that strategy, or else I'll be just doing strategies every day. But the point is, you should also implement it. I don't have a problem doing strategies. That's the reason why I don't do many strategies, because there is a point where you need to understand, you also need to learn. The best strategy is to learn, the best strategy is to watch videos, watch lectures and start solving questions. That's the supreme most strategy, bacha. It's not watching strategy videos. So yes, I will conduct strategies when it is the right time for all of you. Don't worry about it. Yeah. So deviation of light by a plane mirror. That means light was coming like this. It gets deviated this way. It deflects. This is called as the angle of deviation, and that angle of deviation is 180 minus 2 pi. So very simply put, look at this. This is the actual ray. This is where the ray was going to go. This delta is basically your angle of deviation. This angle of deviation delta will be, this total angle is 180 degrees minus I minus R. But we know that I and R are both equal. So it will be minus I. So it will be 180 degrees minus 2i. But in radians, you can also write it as pi minus 2i. If I is in radians. So this is in degrees. This is in radians. That's the only difference. Okay, so keep this in mind. Alright. So very easy, and let's solve some questions based on deviation of light rays. Here comes the first question. Beautiful one on your screen. Join in. Even if you are joining in late, start watching, and whatever you have missed, you can even watch now by taking the slider behind, or you can watch it after the lecture ends. Nothing is going to get erased. Two plane mirrors are inclined to each other. They are inclined to each other, okay? Some angle between them. So that the ray of light falling on the first mirror and is parallel to the second mirror is finally reflected from the second mirror parallel to the first mirror. Wait a minute, what is happening? Think carefully. The angle between the mirrors will be the mirror 1, alright, on which the light is falling, is making some angle with the second mirror. The light which is coming and it's falling on the mirror 1, it's initially not parallel to M1, it is parallel to M2. After it reflects, and it reflects from the second mirror, that time it is parallel to the first mirror. So first think, what will the diagram look like? So you need to visualize that. Okay, let me just draw a small little diagram for all of you. So think about it. If these are the two mirrors, the light, this is M1, this is M2. The light which falls on M1 is initially parallel to M2. You can say it is parallel to M2. After reflecting from M2, then that light ray is parallel to M1. So this is how the ray diagram will look like. Alright. So let's see whether I have those ray diagrams right over here. Yes, I do. And let's start marking the angles. M2 is parallel to the second reflected ray. M1 is parallel to the first incident ray. Correct? And whenever we know we have parallel lines and you have a line which is intersecting, these two angles are equal, right? You have studied that back in 9th or 8th grade. So when you have these two lines, think about it. if this is theta, this line and this line, obviously this angle will be theta. Do you agree with that? For these two lines, if this is theta, this is a line which is intersecting, this is theta, fair enough. For M2 and 2, if this is theta, obviously this is theta, because two parallel lines, same line intersecting, these angles will be theta, fair enough. Next, think, because angle of incidence is equal to angle of reflection, that means if I draw normal, this angle will be equal to this angle. This will be angle of incidence, this will be angle of reflection. So if that is theta, obviously this will be theta. Got it, my warriors? Because that side and this side, the rays should make same angle. That is laws of reflection. Same thing, if I draw normal here, this angle should be equal to this angle. This angle should be equal to this angle. That means this angle should be also equal to this angle. Angle of incidence equal to angle of reflection. That's it. Theta, theta, theta. What do you see, guys? Do you see a nice do you see a nice equilateral triangle right over here? I can see a nice equilateral triangle right over here. That means what should be the answer? It should be 60 degrees. So this is obviously an equilateral triangle. Hence the angle should be 60 degrees. Theta is 60. Fair enough. Very good. So completely based on geometry. That's why the chapter's name in many books is also geometrical optics. Beautiful question. Moving on to the next question coming up on your screen now. A light beam which is getting reflected by two mirrors, as in a periscope used in submarine. If one of the mirror is rotated by theta, the reflected light will deviate from its original path by how much? I will help you with the diagram. Imagine this was the mirror. Okay, imagine this was the mirror in the first position. Okay, let me just show you the normal right over here. And this is how the light is incident. It's coming like this and it is getting reflected. Okay, this is the first case. This is the incident ray. If you rotate the mirror, then what will happen to the reflected ray? That's the question. Let's see how we can do this. Yes, Abhishek, I will definitely use the mic in the next class. For today's class, please adjust, alright? So for today's class, just make sure you somehow adjust. I'll assure you next time the sound will be fine. Okay, A, is it? Let's see. Think about it. Alright, let's see how we can solve this. If you rotate the mirror, that means now the mirror goes, oops, not this. The mirror is turned by a certain angle, like that. This is the mirror's new position. You have rotated it by theta. Okay? If you rotate the mirror by theta, even the normal will rotate by theta. If mirror and normal are perpendicular, if you rotate the mirror, the normal will also rotate, right, by theta. So you will have a new normal. You will have a new normal. Agreed with this? This is the new normal drawn to it. And this angle will also be theta. Now, here is the basic understanding. The angle of incidence, has increased by how much? Look at that. If this was the angle of incidence, can you see from the new normal, the angle has increased by how much, my warriors? It has increased by theta. Agreed? So by laws of reflection, by the law of reflection, the angle of reflection, what should happen to the angle of reflection? It should also increase by theta. Do you guys agree with that? It should also agrees with that. It will also increase with that. Do you guys agree with that? Pakka? So the angle of reflection will also increase by theta. Now it will increase by theta, but not with the old normal. That's the catch. Understand? This was your old normal. This was your old normal. understand the angle of reflection has increased by theta, but the normal itself has tilted by theta. So the angle of shift of the reflected ray, see, understand, the reflected ray which will be now going here, somewhere. This ray will now be deflected by some angle, and this angle will be how much? Theta because of this and theta because of the shift in the normal. So this will be 2 theta. 2 theta. Yes, correct, Utkarsh. Very good. Very good. Anish, it's not C. So a lot of people think it should be C. Understand, the angle of reflection has increased by theta, but the normal itself moved by theta. So theta and the normal also shifted. So 2 theta. Understand this. I'll repeat. This was the old normal. Okay. So the angle of reflection should increase by theta. Fair enough. The angle of reflection should increase by theta. But the normal also tilted by theta. So the reflected ray should tilt even further by theta. So it should be 2 theta. Very good question. Alright. Hi Sujay. Welcome aboard. So this is how you solve this question. And remember this answer is 2 theta. That's something which you should also know as a fact. There were questions in JEE where there was a mirror and that mirror was rotating at omega and the light was falling on it. There was light which was incident on it. The reflected light was rotating at 2 omega. This is how the reflected light was rotating. Why? Because if the mirror rotates by theta, then the reflected light will rotate at 2 theta in the same time. So if the angular velocity of the mirror was omega, the angular velocity of the reflected light was 2 omega. These kind of questions have come, my warriors. Yeah? Okay. So I hope this is clear. Yes, the notes of this is there. Yep. The notes of this is there, okay? So I put up the theory slide as well for you. Okay, just in case you need it. But if you want to see my explanation also, that is also there. This is not going to go anywhere. My PDF will be available on our Telegram channel. Moving on now to mirrors which are moving, objects which are moving, and they'll be moving in a crazy fashion. Right? Are you guys geared up? Ready? Yeah? Show some support and show some fire in the chat box, my warriors. Let's move on to moving objects and mirrors before we go to mirrors which are at an angle. Very interesting concept as well. See, it's very simple. Object and image distances are always same, correct? I'll go right over here. The x, which is the object distance with respect to the mirror, is always the image distance with respect to the mirror. That's what it is, object distance. Object distance, the distance measured from the mirror to the object, and the image distance, which is the distance measured of the image from the mirror with respect to the mirror. They are always equal. So if I differentiate this, dxom by dt is equal to dxim by dt. Differentiating on both sides, I will get the velocity, because derivative of position is velocity, derivative of distance is velocity. So velocity of the object with respect to the mirror is velocity of the image with respect to the mirror. This is all magnitude wise, please keep that in mind. So very, very important. Very, very important. So if the object is going here, image will be going the other side. The directions are opposite. So many students also, or many books also put up the minus symbol over here. The minus symbol only stands for the direction. Otherwise, magnitudes are same. Okay. Okay. Now I have a question for you. What if the object has a velocity here? This is the velocity of the object perpendicular to the mirror. Then what will happen to the image velocity which is perpendicular to the mirror? Look at this. If the velocity, or I would say, just think of it this way, it's parallel to the mirror, not exactly perpendicular, because perpendicular will be other way. If there is some other component, then what do you think will happen to that other component right over here? Let's say this V1. Then in the image, that velocity will be as it is. It will be also as it is. Keep this in mind, because see, if the mirror is here, if you are moving parallel to the mirror, then your image will also go like that only, right? It will be very weird if this is the mirror, you walk this way, your image walks that way. It will be so crazy, you will get scared, you will think you are a ghost. So, if the object goes here, the image behind the mirror should move along with it, it cannot go opposite. So, keep this in mind. So, all the components along the mirror just are as it is, there is no change in that. I hope this is clear. Yep, very good. Yep, Vaishal, even 11 students can watch it. We have, yes, just like Anish said, 8th standard students also watching this class. Now, there will be questions where mirrors are moving. What will you do in that case? Just understand, if mirrors are moving, sit on the mirror and solve the question. I will repeat. If mirror is moving, okay, simply what you need to do to solve it, sit on the mirror, not literally, make the mirror as a frame of reference and solve the question. And then do not forget to convert it back to ground frame. Convert it back to ground frame. That's what you need to do. Keep this in mind. Very, very important notes right over here. Let's solve some questions coming up on your screen. Yes, it is not possible, Ankit. I mean, if you go like that and the mirror is here, the image has to move with you. Imagine this board was the mirror, the image has to go with you. It will be very weird if the image goes that other way. Okay, let's see how you can solve this question. The velocity of the image when the object and the mirror both are moving in the same direction and not same direction, they are moving towards each other with velocity 2 and 3 respectively. So this is the object. The object is moving with 2 meters per second. Okay, this is 2 meters per second. This is the mirror. Okay, this is the mirror. This is the image. I don't know how it is going to move, but the mirror is going like this with a velocity of 3 meters per second. Question is, what is the velocity of the image? Come on, let's see how many of you can get this in the first shot. Anish, it may be inertial, non-inertial, and Newton's laws, we don't care about it in reflection or refraction. We are solving ray optics, so we are not going to apply pseudo force on light. So don't have to worry whether it is inertial or non-inertial frame. Okay, so GSK Telugu gamer, there is a link in the description box. Go ahead, click on the link, you will be able to join it. Alright. Oh, welcome Pubia. Good evening Kshitija. Join in. Lot of students from Tamil Nadu out here. And we started this channel especially thinking in mind that a lot of students from the south, even in northeast, and many students even in the north or even the western part of India who study in English medium, they needed a channel in English. So welcome aboard. Okay, B or D, considering which direction we considered positive. Okay, I'll tell you, only one of them will be correct irrespective of the signs. Forget the signs. I know it sounds confusing whether it is plus or minus. It doesn't matter. Just look at the magnitudes. So if it was plus 10, minus 10, then it will be tricky. Then you need to know which is positive, which is negative. But here it really doesn't matter. Okay, so let's see what you should do. Remember, when mirror is moving, sit on the mirror and then solve the question. So sit on the mirror and solve the question, meaning let's make the mirror as the frame of reference. So the mirror is at rest. What will you see the object doing? What are you going to see the object doing? The object is going to move with what speed, my warriors? Think about it. The object will move with what speed? Think, you are the mirror is going with 3. 3. And the object is coming towards you with 2. So for you, with what speed will the object come towards you? You are moving towards it, object is coming towards you. It will appear to move with 2 plus 3, which is 5 meters per second. Everybody agrees with this? 5 meters per second, agreed? Similarly, now think, if the object comes towards you with 5 meters per second, that image behind will also come with 5. Both will come with 5, right? So the image will come with 5 meters per second like this. But this is all with respect to the mirror. Keep this in mind. This is all with respect to mirror. Now, think about it. Mirror is itself moving 3 meters in 1 second. I'll repeat. Mirror is moving 3 meters in 1 second this way. So in 1 second I moved 1, 2, 3. With respect to me, the image has moved 5 meters. So think about it. I moved 3. The image moved more 5. So how much did the image move for you? You are going behind. Go in reverse, do reverse calculation and think. The mirror has moved how much? The mirror has moved 3 meters. 1, 2, 3. And the image moved more 5. So how much did the image actually move? Think about it. The image moved 3 just because of the mirror and more 5 because of the reflection. So totally it has moved 8 meters per second this way. 8 is basically 5 plus 3. That's what has happened. So hence the answer will be 8 meters per second, but this way, so minus 8. Got it? Understood? Clear? It's not 10. Many students make that mistake. So understand it's not the relative speed between object and image. Many students who are answering it as 10 are thinking you have been asked speed of the image with respect to the object. No. Speed of the image with respect to the object is 10. Agreed. 5 and 5 becomes 10. But here the question is what is the velocity of the image? When they ask you velocity of the image, it automatically means with respect to the ground frame, nothing else. With respect to the ground frame. Alright, let's get going to the next one. Option A is correct. Very interesting question where the mirror is moving at an angle. Interesting. Mirror is moving at an angle, not the object. Object is fixed. You are moving the mirror. Very interesting question. Let's see what to do. First things first. Split the velocity. Without splitting the velocity, you will not be able to do it. Thank you so much, Amit Varshini. And Nishant, today is not my birthday. Alright, so what you need to do, split the velocity and understand which component is mattering the most. So, split the velocity. There are two components of velocity. One component here, one component here. This is V cos theta. This is V sin theta. Okay, think of each component separately. Look at this. If there is an object here and there is a mirror, if the mirror moves like this with some velocity, what do you think will happen to the image? Will the image also move? Left, right, up, down? Answer in the chat box. Think. Object is here. It is not moving. Object is fixed. Object is fixed. The mirror goes this way. What do you think will happen to the image? Will the image also move left, right, top, bottom? Or will it not move? Think about it. Obviously, if the mirror moves, there is nothing more to change. The rays will still reflect like this. The image will still be formed here. The image will also be fixed. It will not move at all. Nothing will happen, yes. Why should anything happen? Mirror is just moving. It's like, imagine this board is the mirror. The board is the mirror. I am standing here. I am not doing anything. Somebody moves the board. Somebody drags that board. Will my image also start moving? I will be scared if that happens. So it's not got to do nothing with it. So here, because of this component, nothing will happen. Nothing happens because of this component. But something will happen because of this component, V sin theta. Let's visualize what will happen. And here is this part now. Okay, let's see what will happen because of this. So imagine this is the object. This is the mirror. The mirror moves with some velocity like this. The mirror moves towards the object with some velocity. What do you think will the image do? What do you think will the image do? Will that image stay quiet? No. The image will also move. If object distance reduces, image distance also reduces. If object distance reduces at some velocity, then the image distance should also reduce at the same velocity, but it is all with respect to the mirror. Remember, mirror is also moving. The image will also move with the same velocity with respect to the mirror, but since the mirror itself is moving, this image will move with 2 times the velocity. 2 times the velocity. Think about it. Why 2 times? If you have not yet understood, I will explain it to you in a different way. Okay, look at this. Think of the mirror. Just think of the mirror's frame of reference. If you sit on the mirror, what will you see the object doing? You will see the object coming this way with some velocity. Agreed? That means you will see the image also going this way with the same velocity. This is all with respect to the mirror frame of reference. Now, with respect to the mirror, the image is moving with v, but the mirror itself is moving with v, so the net speed will be 2v. Is that making sense? Understood, my warriors? Pakka? Got it? Very, very interesting concept. Twice the speed. That means, because of this component v sin theta, the image which is there will move with 2 times of v sin theta, which is there as option E. Yep. Is this amazing? Isn't this amazing question, my warriors? It's a brilliant question. So, what have we learned? When you slide the mirror like this, there is no change, because the object will form the image here only. So this component was useless. When mirror moves with velocity v, then the image will move with twice the velocity. So that's why 2v sin theta, as simple as that. Brilliant question. Moving on to the next one. Okay. Now this is very nice question, advanced type question, where velocity of the object is 5i, 3j, 11k. All the signs are mentioned. Vm is 2i minus j minus 3k. Question is, what is the velocity of the image produced by the mirror? It's a brilliant question. Let's see how many of you can do this. In 3D coordinate system, the mirror is along the xy plane. The mirror is along the xy plane. So let's draw it and see what and all we can infer from this. So let's say this is our xy plane. Okay, so this is your xy plane. Interesting. Alright, and then obviously this will be our axis, and velocity of the object is given. Okay, this will be the z axis for sure. Okay, so let's say this is your z axis. Okay, that side will be negative z maybe. So hold on. Yep. So this is your z axis. Oops, 1 second. Yep. So this is your z axis, positive side. That will be your negative side, z axis. And the object's velocity is given. This is the velocity of the object, 5i minus 3j minus 11k. Now I'll tell you what. Here is a simple trick. All the velocities I just told you, if there is a mirror and if there is an object, if the object is going with some velocity parallel to the mirror, the image will also go with the same velocity. Did I not tell you? This velocity is equal to this velocity. They both will move like this. So z-axis is actually normal to the mirror. This is the normal to the mirror. Normal to normal, perpendicular to normal is parallel. Two perpendiculars, perpendicular and perpendicular makes it parallel. So whenever velocities are parallel to the mirror, nothing happens. It just goes with the same velocity. Everybody agrees with that? So here the k cap component, all the components along z-axis are normal components. That means take those components which are along with the mirror, along, parallel. That will be 5i cap. Okay, that will be 5i cap minus 3j cap. If this is your object velocity, remember image velocity will also be 5i cap minus 3j cap. The first two parts are done. Remember this, because the velocity components will not change. Are you guys getting this, my warriors? For sure. Very good. Now, the only thing remaining is what happens to the k cap. Look at this, minus 11 k cap. Okay, let's deal with that as well. So let's draw it. So minus 11 k cap. This is your minus 11 k cap. Because of the object's velocity, obviously the image velocity will also be there, okay, on this side, but hold on. There is a mirror as well, and the mirror also has certain velocities. But out of that, these two components will not even matter. They do not matter. They don't matter. Why don't they matter? Because they are parallel to the mirror. If they are parallel to the mirror, they won't matter. I cap and J cap will not matter. Only these velocities matter. These normal velocities, z-axis velocities will matter because they will only change the distance. When the mirror goes like this, nothing will happen to the image. Got it? Okay. So, what is the mirror's velocity? Minus 3 cap. Interesting. So, the mirror's velocity is minus 3 cap. That means the mirror is going like this, minus 3 cap. Interesting. Let's reevaluate the situation. The object is here. The mirror is here. So what will be the object's relative velocity with respect to the mirror? Object is moving with 11, mirror is moving with 3. Object is moving with 11, mirror is moving with 3. What is the relative velocity between them, my warriors? Think about it. What is the relative velocity between them? 11 minus 3, which is 8 meters per second. Isn't it 8 meters per second? That means the image will move 8 meters per second. This is all with respect to the mirror. All with respect to the mirror. This way, 8 meters per second this way. Got it? Now last step. Understand this step properly, my warriors. Yes, pay attention carefully. The image goes 8 meters in 1 second with respect to the mirror. And the mirror, with respect to me, it moves 8 meters. But I moved 3 meters ahead. Look at this. 3 meters in this direction, and the mirror, for me the image moves 8 meters this way. I move 3 meters. So how much has the actual image moved? Think about it. How much has the actual image moved? Think about it carefully. I'll repeat once more. The image has moved 8 meters. You moved back 3 meters this way. 8 minus 3. So 8 minus 3. So basically you have moved how much? You have moved 5 meters per second this way. But this side is positive, so it will be plus 5 k cap. So hence the final answer will be plus 5 k cap. Is that clear? Everybody understanding this point? Got it, my warriors? What a brilliant question. Yep, fair enough. Very good, Abhijit. Yes, Vaishal, it is very interesting. And this is a brilliant question. It had so many steps, so many concepts, and I'm pretty sure if you have studied this chapter and if you have not studied this in detail, now you would have learned so many new things which otherwise you would have skipped, and you would be like, oh, plane mirrors? Why is sir taking a big marathon session, one shot for plane mirrors? Now you know why. So this is the answer. Moving on to the next one. Okay. Selvakumar, if that's so, I'm not sure what has happened. Probably the drive links would have changed, that's the reason. But let's see if I can get it fixed. Imagine two mirrors at an angle and how they will produce different images. And you would have seen this many times. Something like this. Look at this. You have two mirrors, maybe in a dressing room, maybe at the barber shop, and this is one object. It can produce multiple images like this. Or take the example of this one. There are two mirrors inclined at an angle. You can see the images formed over here. Do you see that? These are multiple images. Certain things are very interesting in this. What's the most obvious thing about the images? Come on, everybody should be able to tell me this by looking at all these images of this particular object for inclined mirrors. These are two mirrors. This object will form an image here. That image's reflection will be formed over here by the second mirror. This image will be now the object for this mirror. It will get reflected here. This image will now be the object for this mirror, and it will get reflected here. Now this will be the object for this mirror. This will get reflected there. That will get reflected here, and it will keep on happening till the end. What is interesting about it? What is interesting about it? Which Vaishal saying pizza. Yes, very similar to a pizza, but something else, very close, but Oh, Dhaneshwar, no, I have not yet seen it, bacha. No time. I myself went home. Yeah. In fact, yeah. Did I change my studio, Akash? No. In fact, I've changed my mic, so I'm realizing that I need to put some sound absorbers. Guys, I need a feedback from you. Is the sound better? I know there is echo, but is the loudness, is the clarity better? Because echo I can get rid of. I just need to put some more curtains and some more cushioning. That echo will go off. But is this mic better than my older mic? Okay. If it is better, I will continue with this tomorrow, and I'll just put some padding material through which echo can be reduced. Yeah. Okay. So if that's so, all right. Multiple images. Yes, you get multiple images. One more thing, pizza, that means circular form. All the images are in the form of a circle. Can you see that? Yeah, it's like in a form of a circle. Number 3, you will see that the images which are formed in succession are fainter than the previous one. This is bright, less bright, less bright, less bright. Because after multiple reflections, the rays get scattered. So each image that is formed is fainter and they all are in a circle. There is a very easy way to find how many images are formed. Many students try to remember a formula and they screw it up. Don't mess it up. Okay. Very easy. What you need to do is remember, okay, this simple rule. I'll ask you one simple question. If you have a mirror here, okay, and you place an object O1 and object O2 like this, out of these two objects, which object do you think will form an image? Look at this, O1 and O2, this is the mirror. Out of these two objects, which objects do you think can form images? Think carefully and answer. Well, I'll put one more object just to create some interesting confusion. O1, O2, O3. Okay, I'll add one more object, let's say O4. Now tell me. Okay, so here is the answer, guys. Simple. O3 is in front of the mirror. Obviously, this will produce an image. Obviously, O3 is in front of the mirror. You'll be like, sir, O2 is not in front of the mirror. I agree, but there will be rays which will be going like this. They will be getting reflected, right? They will be going like this. They will be getting reflected. They will definitely produce image behind. So O2 will also produce reflection. They will also produce image. But O4 and O1, they are behind the mirror. So whenever objects are behind the mirror, they will not be able to produce any images. Everybody agrees? So Anish, the question was, out of O1, O2, O3, O4, which objects can produce image? The answer was O2 and O3 because they are in front of the mirror. The rays can get reflected. O1 and O4, the rays will not be able to get reflected. They are behind it. Fair enough. Now, here is what I will do. Look at this particular question. The object is right over here, and let's start with this. Let's assume this is 45 degrees and this is also 45 degrees. This is an object, M1 and M2 are the mirrors. M1 will form an image right over here. It will reflect it exactly at 45. So at 45 degrees, I will draw image 1 because of this first mirror, and this angle is also 45 degrees. Agreed? This image will now be the object for this mirror. This mirror reflected it. This image will now be the object for this mirror. So, is this image in front of the mirror? I'll repeat. Is this point in front of the mirror? Yes, it is. So, it will be reflected behind the mirror. This object is in front of this mirror M2, will be reflected behind the mirror. So, hence, you will see another reflection right over here. This will be the next one. If this is 45 degrees, this will be also 45 degrees. Now you need to stop. Why? This image will be the object for this mirror, but this object is behind the mirror. I'll repeat. This image, which was reflected by mirror 2, is now the object for M1, but for M1, this I2 is behind the mirror, so no further reflections. Vishnuvardhan, now for the last few months, it's the same Pathfinder but in a new form. Now we are calling it one-shot marathons because I'm going to complete more portions in these classes. Yep, I hope this is clear. Sahil, yes bacha, you can get even all India rank 100. You can do whatever you want, even if you put, when you put maximum efforts, obviously the entire, I would say the universe conspires against you and conspires with you, and they will make sure that everything goes for you. So don't worry about what has happened before this. Don't worry about your marks before this, but if you are able to put sincere efforts for the next 6 months, 5 months, definitely it is possible. And JEE Advanced is not going to happen before June. It will happen only after June. So that gives us a good window to prepare. Okay, now that's where we stop. But I forgot one thing. This object was reflected here. Same way, this object will be reflected this side. So let's do that as well. So this object will also be reflected here. So you will form an image I1 or rather I3 over here, I would say. Okay, right over here. This will be also 45 degrees. This image will be the object for M1. It will be reflected here exactly on this. So this will be the next image. Exactly, it will get reflected right onto this. Now, will you count these as two separate images or one image? Obviously, they are forming on the same thing. This is just one image. So 1, 2, 3. 3 images form. You can see that 1, 2, 3. Do you see that, my warriors? Do you see that, my warriors? Yeah. So that's how you get 3 images because of 2 perpendicular mirrors. And you can see that right over here. Everybody understood? Let's do a question just in case you want more practice. Here is a question in front of you. Anish, you will understand it probably in this question, but just to give a quick roundup, what happened? This object got reflected here because of mirror 1. Because of this mirror, this got reflected here. Because of this mirror, this can't be reflected in the front because this is behind this. So 1, 2, 3. Sorry, 1, 2, 1. Now this object will get reflected because of this mirror. Correct? And this will get reflected behind over here because of this mirror. After this, you cannot do anything further because this is behind this mirror as well. That means you have 1, 2 and 3 images because these 2 images have coincided with each other. That's why you got 3 images when the screens, when the mirrors are perpendicular to each other. Okay, let's solve this for this question. Okay. If 2 mirrors are at 60 degrees, now don't by heart these answers because if the angle changes, then what will you do? So remember the procedure. Then how many images are formed by it? Let's solve this by my method. It's very easy. Just follow me carefully because I will not be able to repeat this again and again. Okay. So let me just draw the mirrors. Okay, I will just draw the extended lines like this. So this is the mirror. Okay, and the mirrors are kept at an angle of 60 degrees. So this is basically your 60 degrees. Okay, now let's start with it. Let's say our object is over here. Our object is over here. Let's say for simplicity, let's keep it at 30 degrees. This is your 30 degrees and this is also your 30 degrees. Okay, so let's start doing this question. Simply put, this object will be reflected by this mirror. So I'll also label it if you want. This is M1, this is M2. Object will be reflected by M1, so it will be reflected 30 degrees behind. If it is 30 degrees front, 30 degrees behind. 30 and 30 will give you 90. That means this will be the first image which will be formed here. This will be I1. This will be formed exactly here. This is 30 degrees. Agreed, my warriors? 30, 30, 30, 90 degrees. This is 90 degrees. This image will be reflected because of M2 behind it. So exactly 90 degrees behind. So this will be I2. This will be I2. Okay. This will be 90 degrees. Fair enough? Okay. If this is 90, what is this angle by the way? Oh, this is 30. So naturally, this will be also 30 degrees. So this image will be reflected here. This is 30 degrees in front, 30 degrees behind. So somewhere over here. So you will see a reflection right over here. I will call it I3. Got it? If this is 30, this will be also 30 degrees. Now, this image, because of this mirror, can't be reflected because this image is behind. Can you see this mirror? When you draw that line, is behind. So no more reflections will occur. Got it? Now, last thing. We need to go back to the other mirror. We started with M1 and then we kept on reflecting. Now we need to start with M2 and see the reflections. Observe it carefully. This object will get reflected here exactly 30 degrees. So this will be 30 degrees. So you will get one image over here, I1. Okay, this is the first image because of the first reflection from the mirror. 30, 30, 30. This is 90. This is 90 degrees, the green and the black line. This image will be reflected behind M1. So you will see another image over here, I2. Fair enough? Okay. Now this is 90 degrees. If this is 90, think about it. This is 30, this is 60. That means this will be again 30. Good. This image will be reflected here because of this mirror. This is 30 degrees in front, 30 degrees behind. 30 degrees behind is exactly over here. It will be reflected on this. That's it. After this, you cannot have any more reflections. That's it, done. Now count the images. 1, 2, this is 3 because they are coinciding. Don't count it separate. 1, 2, 3, 4, 5. So 5 images. Hence the answer is A. Done, done, done. Shining, using formula, it is simple only for certain angles. There are different cases, different formulas. I know many of you might remember 360 divided by theta minus 1. Sometimes it is 360 divided by theta minus just by theta. Sometimes it is not minus 1. So, you know, it might be confusing. It's better you do understand this procedure because right now while explaining I am taking time. But if you give this problem to me, I will take not more than 20-30 seconds. Fatafa, tak 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 tak, I will solve it. It's just a matter of habit. Else you will get confused whether you should do minus 1 or should you do plus 1 or should you do nothing. Should you take greatest integer, should you take least integer, because there are different cases in it. Object is placed symmetrically, object is placed asymmetrically, theta is odd, even. Why do you want to get into all of that? So better to do it like this. Okay, let's do one more question. This is a proper JEE question. Okay? Dinesh, start from the beginning. Go back right over here. Go back over here. See this explanation. Start from here. You will definitely be able to understand because this is the method to understand. I know many teachers, many institutes give this formula. 360 by theta minus 1. Done. That's what they do in so many institutes. Students are like, sir, how? Doesn't matter. Remember the formula. 360 by theta minus 1. 360 by theta. This is odd. This is even. Why, sir? Just by heart it. Then what's the point? What's the point of learning physics? Then I might as well not teach physics. I can just give you a formula book. This is the case, this is the formula. This is the case, this is the formula. Then there's no fun. Alright, Dinesh? So you can just watch the session part again, whichever you have not understood. Definitely you will get it. Bacha. Okay. There is a light source kept here. Think out of these three observers, A, B, and C, which of the observers will only see one image? One image. Exactly one image of that source S. Think about it, my warriors. There's only one particular or maybe two people who are going to see exactly one image, not more than that. Which one it is? Think carefully. Okay, here's the logic for it. Just draw the rays which are getting reflected and see if they can pass through A, B or C. For the source S, if the rays come like this, they can obviously pass through B. Okay, so if they pass through B, that means the source's image will be formed behind. B will feel the source is here, correct? If the rays get reflected. So B can see definitely the image behind this mirror. In fact, even A can see, I'll tell you how, something like this. Look at the rays. If the rays come like this, the rays come like this and they go onto A like that, A also can see S behind the mirror because A will feel the rays are coming from behind. Agreed? Even for C, you can feel the same thing, but understand, this mirror rays can only get reflected here, this lower mirror. They can never reflect from here and go on to C. It's not possible, right? Because S is over here, this is the mirror. How can the rays get reflected and go on to see like that. This is not possible. It's impossible. It violates the laws of reflection. Fair enough. Now, there are more rays that I can draw. Look at this. The rays coming from here can pass through C like this. The rays coming from S can get reflected from this mirror and also pass like this. The rays coming from, okay, very interesting, going like that and going like this. So do you see A can also see these rays reflecting from the other mirror? B can also see the rays getting reflected from the other mirror. Look at the rays, blue and red, blue and red, blue and red. So here you have two images at least. Here you have two images at least. Okay, in fact you will have more than two images, maybe possible if the rays get reflected again. Here on C, once the rays enters this mirror, there is no chance they will again come back on C. Because even if the rays get reflected here, they will come on this side, they can never go to the other side. So here it will be only one single image. Do you guys get it? So for C, the answer is only one. Option B. Very good. Madhvi, it's not C, it's only B option. B option. All the other rays you can see which fall on this mirror can fall on A or B. But when the rays fall here, they can never enter on C. You can see on this mirror when the rays fall, they can go to B, they can go to A. So these observers A and B can at least see two images. But C can only see one image because he can see only one reflection. What a brilliant question. Abhiram Chaudhary, very simple. If your maths teacher told that you cannot crack JEE, then you tell him that I can crack JEE and you show it to him and then you prove him wrong. As simple as that. It's very simple. Okay, you don't have to get affected. And number two, if you can get affected by some teacher or somebody telling you you cannot crack JEE, then get affected by your physics teacher telling you can crack JEE. As simple as that. I am telling you can crack JEE. Now will you be worried? Now will you take me seriously? So why are you getting affected by somebody who is telling you that you cannot crack? Get affected by the person who is telling you can crack JEE. I hope that helps you. Okay. So that's the answer. And now let me also tell you there is a Telegram channel of ours. The new channel. If you have joined the old channel, please join the new channel because that's where you get the PDF. Whatever I write, everything updates. This is your first homework question. You have to post the answers in the comment section below. This is your second homework question. Take a screenshot. You can pause the video obviously and take the screenshot and post the answers below. This is your third homework question coming up on your screen. And yeah, I will also tell you that there is a last day for our 50% discount which is running because of Pongal sale. And that's for the JEE crash course where you will get 90 classes live plus recorded. You will also get the test series, also full half syllabus, part syllabus test series, plus all India rank comparison test series, assignments for every chapter, doubt solving also is included, and also you will get notes, PDFs for all the chapters. All of this was usually at 20,000 rupees. There is already a 50% offer running because of which you get for 10,000 rupees, and then Pongal sale, because of which you get special discount, more 2,000 rupees off. Usually the discount used to be 1,000 rupees, 10% off. Today you have 20% off. The offer is only valid till tonight. So please keep this in mind. If you want to join the crash course, it's very simple, my warriors. I'll tell you where you can join it. Well, let me just put it up on the screen right over here. All you need to do is just 1 second. Yep. So if you are on our channel right now, okay. So let me just click on this. Yeah. Just click on this video. Just go below, and do you see the JEE crash course? That's it. 50% off up to 2,000 rupees. So if there are some courses which are at lesser value, you get 50% off. Remember, maximum limit is 2,000 rupees. Click on this link. That's it. You can join the crash course. Plus, I will be there on the crash course, and this crash course is in English medium. Keep this in mind. Now, you just have to click on buy now, and that's it. There are many payment options that are available for all of you. So I would be very, very interested to see all of you over here. you have two options, 10 Jan and 17 Jan. You can choose 17 Jan as well if you want to start the classes as early as possible. But if you want to go back and watch the recorded classes and you want to complete the course early, then choose this one. It's up to you which one you want to join. So I'll be seeing you. I'm very excited to see you in the crash course because even I will be there in it. And thank you for liking the video, my warriors. Thank you for your immense support and immense, love that you keep giving all of us. Yep, the class is over. Now next class we'll have reflection at curved surface, that is concave and convex mirrors. Then refraction at plane surface, then the refraction at curved surface, and prisms, lenses, combination of lenses, all of that. That's how the chapter will get over. Okay. So Subraja, my sample paper for term 2 is not yet there because I could not conduct the class on Saturday. I will be conducting it tomorrow or day after. Just give me some time. Okay, there was some net issue. Let me just arrange for some time and find a time slot and just conduct the class and also give you the strategy for term 2. Alright, so don't worry. Okay, till which first portion nurture series? Nurture is for 11th standard portion, and right now I am on to thermo. The only chapter which is left is waves after thermo. So once I complete thermo in the next week or so, I will be starting waves. So by February first half, I think waves also should be done. Right? Chalo. Thank you guys. Take care. Have a great time. Stay safe and stay well. Stay healthy and do your homework. Bye bye. This was Shreyas here. Capto. Signing off. Hasta la vista.